I'll go ahead and get started. My name is Laura Saba. I'm co-director of the NIDA Center for Excellence in Omics Systems Genetics and the Dictome. Welcome to our webinar series. I believe this is number 19. In our webinar series, where we just kind of go over different tools and approaches and topics related to quantitative genetic studies in rodents. Our whole archive is on our website at opart.io. If you want to watch any of the other presentations online, the way this works is, if you happen to be on earlier, is we'll have Hao present for about an hour, and then we'll leave another half an hour for discussion for those that want to stick around and talk a bit more about what was presented. I do ask that everybody keep themselves on mute during Hao's presentation. If you have questions, you can put them in the chat, and Shanak will be monitoring the chat. And so he may stop Hao if he has things that he thinks are important to ask at that moment, but he'll save the other questions that are better for the discussion time till a little bit later. I think that to give you a preview, we do this the second and fourth Friday. And so the next one coming up is going to be organizing data and spreadsheets, and that is going to be presented by Carl Broman. So we've got that going next month, but you will have to re-register again. We are recording, and we'll make this presentation available on YouTube. So I think that takes care of my housekeeping things. And so now it's my pleasure to introduce Dr. Hao Chen at the university. He's an associate professor at the University of Tennessee Health Science Center. He got his BS and MS in Beijing and then went to Michigan State University for his PhD. I've been working with Hao for the last 4 or 5 years, and I've always been impressed. I like to call him the MacGyver of rodent studies, that he knows how to make all his own apparatuses, prints out the plastics that he needs, and then sets up all the computers. So I'm really excited to hear his presentation today. So feel free to start whenever you're ready, Hao.
Okay, thanks Laura for the introduction and the invitation to give this presentation. Okay. Can you see my screen now?
Yes, we can see it.
Okay, so the title is a Rube Goldbergian, if I can pronounce the word, approach to scheduling rodent behavior experiments and data collection. Rube Goldberg's inventions is featured on this US stamp. I don't know if it's real or fake, but in this picture, this invention depicts a automatic napkin that wipes your face when you lift your spoon and try to drink the soup, which is the spoon is A, and A pulls the stream B, and B then pulls the letter C, and that throws up a piece of cracker D, and the parrots goes for the cracker, and then the pail tilts and some seeds dumped into the pail, and then the pail is tilted again, and that sets up the automatic lighter J, and then that lights off the skyrocket, which pulls the sickle and cuts the string, and then the pendulum starts to wipe back and forth, and then that wipes your face. So it's a very simple thing that you just need to do with your hand. You can take the napkin and wipe your face, but this is the complicated way of doing the simple thing, and that's what I'm going to be talking about. Some complicated ways of doing simple things in running rodent experiments. And hopefully it will be clear why we do it this way. Okay, so many of us are doing long-term rodent behavior experiments, and the one I'm going to focus on is operant conditioning, with NIDA funding many of these long-term genetic association studies on operant conditioning, and these experiments usually have very complicated schedules and involves many animals, and each animal has their unique IDs. So you're managing many of these unique IDs. And you may start one batch of animal, and then this batch of animal may go through different stages. You go from fixed ratio 1 to fixed ratio 5 to progressive ratio to extinction to reinstatement. And even if you start a small batch of animal on the same day, once you started the experiment, one animal may run out of sync. A technician may forget to run one particular animal one day, and then you need to keep track of which animal is on which day, even within the same group. And then you might be running different groups with overlapping schedules. So once you have started these procedures, then you have data you need to process. Data need to be processed uniformly, and it need to be processed in a timely manner so that you know what's going on during the experiment and if you need to do any adjustments. And if you happen to do breeding in your lab, then the complexity of the data recording is even more demanding. And there are just so many places that things can go wrong. And what I hope is Rupert Goldberg's approach can help over in some of these situations. So we'll start with setting up the MEDPC program. There are many operant conditioning devices that are commercially available, and MedAssociates MEDPC is one of the most popular ones. That's what we've been using in the lab. So what I'm showing you is the software for MEDPC. I think many of you are familiar with this. To set up one single rat running one experiment, what you do is you double click on the box that you want to set up. Here I click on box 16 because that's the only one that's left available. And I need to enter the subject ID, enter the experiment code, and enter which group this animal is if I have a group assignment. And then I need to open up this drop-down menu and click on which procedure I need to use or which MEDPC program that I want to run. And then I click OK, and then I move on to the next one. So this is not, this is something that's very simple, right? All you need to do is follow the procedures. But imagine you have to do it for 16 rats 2 times a day or 3 times a day. And it's very easy to make mistakes. But this is not the only way you can set up these experiments. So if you look carefully over here, there's the menu called macros. So within the, if you activate the macro, what it does is it records everything you do. And then once you've done it, you can say, this is what I done, and I want to repeat that. So you can just call up that macro, then everything you've done is showing, is going to show up again. So you can imagine that if you are running the same experiment over and over again, you can, it will be a lot simpler. You just spend a little bit of time setting it up once, and then you can use the same macro the next few days. And whenever you need to change something, all you need to do is open this up, and then let's say you want to change from one protocol to another. You load up your macro, and then you change procedure, and then you can, over here, you can say, boxes to load, I want to load 2, 3, 4, 5, 6, 7, 8, and then just click OK, and then all those boxes will be updated. So I'm sure you're all familiar with that. Let's look at what the macro actually is. So if you ever opened up a macro, and you'll see something like this. It's a set of text in a very specific format, which says load box 1, the subject is this ID, and then this, the experiment code is this, and it belongs to this experiment group. So whatever you put in the previous graphical interface, here you can manipulate it in a text format. So since this is a text format, you don't actually need to go through the record macro stage. You can just write the text as if you are programming something, like you are programming in R, right? It's just a program. You can think of this as a program. Then what you can do, or what we've been doing, is instead of putting all these into the macro, we put everything in a spreadsheet, because the spreadsheet is most technicians are familiar with. They can manipulate spreadsheets like pros. So we have different columns for that corresponds to many of these places that's required in the macro. And one thing we've been doing over here is in our lab, we use RFIDs or radio frequency IDs that's embedded in the animal to identify each individual. These RFIDs are quite long, but the first few characters are always the same. They never change. We want to keep the full RFID in the records, but when the technicians are in the animal facility, when they are finding the animals, no one actually goes, where is DCCD00D4? They always go by the last 4 characters that are unique. So we want to give technicians an easy access to the short IDs, but then we want to keep the full ID for the experimental record. So these can all be done in a spreadsheet. You put up the full ID over here, and then you just use the string function to take the last 4 characters. And then we have a program that takes over this spreadsheet and converts it into a CSV file, which is also a text file. And then the program runs through each individual line of the spreadsheet and generate this macro based on whatever is in the spreadsheet. And here is that code. By the way, most of the codes I'm talking about is available in GitHub. I'll show you the GitHub address at the end. So this is a Perl program, but I'm sure you can write it in Python, in any other language. It's just text processing. Takes the text format and then converts into another format, which is not particularly difficult. You can probably write that in R as well. I'm sure you can write that in R, in fact, now that I'm thinking about it. So you don't really have to write in Perl if you're not familiar with it. And then what comes out of it is a set of macros. You can have, in this spreadsheet, you can have many sections like this. And then once you run your code against the spreadsheet, then you get these macros. And since sometimes we only want to run a single animal, so because this is programming, you can do that as well. You can just spill out each line into its own macro. So there's your single animal folder if it's needed. Most of the time we don't really run single animals, but occasionally we want to run a single animal just because one particular chamber is available at the time and others are not available. So when you load a macro, it updates all the boxes in that macro. So having a single animal macro available sometimes can become handy. So that's all put into the same code, and once you run that code, you get the macros. So instead of loading the MetPC program, one animal at a time, now we have a program that takes the spreadsheet and converts it into the macro. And then if you copy the macro into a USB, and you can bring the USB to the animal room, and there you go with setting up the experiment for the day. All you need to do then is just load the animals, put the animal in the chamber. And you don't have to spend time and worrying about making mistakes while you're setting up the experiment. So that is one little circle. But then we need to add a rocket, a sickle, and a pendulum, right? So the first thing we added is Dropbox. I mentioned this is done on a computer. Oops, jumped ahead a bit. That's not in the animal room. We need to copy the macros to USB and bring the macros to the MetPC program. MetPC computer, which is in the animal room. If we add a Dropbox and we can then share the macros between the computer that's been used to generate the macros and the computer that's going to be, the macros are going to be used on. So Dropbox makes that easy. But then we still have to run the program. Can we make it even simpler by having the macros being automatically generated when the spreadsheet is saved? Yes, we can. So there is a script. You can write a script that monitors this particular file now is in Dropbox. And if anything changes to this file, then you run this program that generates the macros, and the macros are in Dropbox. So now the script is monitoring the spreadsheet, and whenever the spreadsheet is saved, then the macros are generated. Then there comes a problem when two individuals running, opening up this spreadsheet at the same time, and they both try to do the same thing. I mean, we have several sections of the of experiments saved in the same schedule file. So they both want to do the same thing. They didn't know the other one are working on the spreadsheet at the same time. Then Dropbox creates something called a conflicted version. And then only one of the versions is going to be converted into macro. And if the other one doesn't know there's a conflicted version, then the experiment that's being scheduled is going to be wrong. So to deal with that, we need a third script that looking for something called conflict versions. And if it sees it, then it sends a message. But where do we send the message to? Well, we can send an email, but they are running their experiments. They're not going to check their emails. Or we can send text messages, but I don't really know how to do that. We happen to be using something called Slack in the lab, and Slack, as I'll explain in a little, in a few seconds, is easy to write app for. So we wrote this attention bot that received this message from the script C, and whenever it sees this conflicted version, it then just pops up a message that there is a conflicted version in the Dropbox. You guys better resolve that. And most of the time, this will be resolved right away because this shows up in the cell phone of the technicians. And now all we need to do is to have a server or a computer that runs all these scripts automatically whenever the computer is started. So I happen to be using Linux, and on Linux, this can be set up in a file called rcroco. And there is my 3 scripts that are started automatically every time my computer is booted. So now, as long as my computer is working, these services will be all run automatically. So now I can go on a worry-free vacation. So I mentioned Slack. We've been using Slack for communication within the lab for a little while, a few years now. It's a commercial solution. And one of the reasons we decided to use it is because user data can be downloaded and archived. And that is something that we treat very carefully. And because if we decide to use it, we want to be able to keep our data. Whatever data we put into it, we want to be able to get it back. And with Slack, that is indeed one option. You can download all your messages in a zip file and you can keep them locally. And another reason is apps are relatively easy to program. For example, if you want to send a message to a particular channel, this is all the code you need over here. It's basically a URL, like over here. This is the ID of your channel, and you send this part as a text string to that particular URL, and then the URL that this channel corresponds to will show up. And in addition to this, this is so-called incoming webhook, just for posting purpose. In addition to this, you can also write slightly more complicated apps, and those are called /commands. And with those, you can also process the data and save the data on your server. So that means you need to have your own server that this app is lives on. So that server also needs to be able to reach by Slack. So that means it must be living outside of the campus firewall. So this is a little bit more complicated, but I'll show you a few examples where this can be helpful in dealing with some miscellaneous data needs in the lab. You don't really need to do this for just posting the messages to Slack. You only need it when you want to process the data and save the data in a format that's convenient for you. So what can we do with this setup? Additionally, what can we do? In addition to setting it up, now imagine your experiments are running and now your experiments are finished. And since these experiments usually run for a few hours, an hour, 2 hours, or 3 hours, technicians can set up a alarm clock to remind them to take the animals out when the session is finished. But since we already have Dropbox set up, why not save the data files into the Dropbox? Then whenever the experiments are finished, the data are available everywhere where you have Dropbox installed, right? Well, since we have the ability to write these notifications, we can send a channel. We have a dedicated channel in Slack where whenever a new data file appeared, we tell the technician that these animals are finished. They can be taken out. So now the technicians don't need to set alarms. Whenever session is finished, they get a ping on their phones, tells them that, oh, it's done. We have the data, we can do a little bit more as well. So we can check if the data is what we expected. So we can look at the session length that's been recorded in the data file. And if we found that it's not what we expected, we can send a message and tell the technicians that, well, it's something went wrong and you can either check it or make sure it's right, it's not wrong, or you can just fix it. So things like this can happen real time, and that's much, much better than a few days later you found, oh, that session, that particular rat didn't really run the full time that it's actually needed. And sometimes there are maybe equipment failures, like we use licking spots as our operant conditioning device. So if there's a 0 inactive lick or 0 active lick, then it could be that the animal actually didn't lick anything. That's normal. Or it could be that that particular spot is disconnected during the session. So whenever the session is finished, if there is a 0 inactive lick, then it generates this kind of message, asks the technician to check it. And then if it's okay, then the technician can just leave a note, says it's okay, or if it's something wrong, then they can leave a note, something went wrong. So here I introduced the concept of a note, and this actually is an app that we wrote that lives in a server that's outside of the campus firewall. So that's a slightly more complicated setup where you do need a actual server living somewhere in a cloud. But with this one, we can here in this case, Tengfei checked this particular cage and left note says, note rat, this particular ID, active and inactive spots are okay. And what happens then is in the back end, the app, the Note app, then converts this message to a very standard format text file. And that text file also is saved in Dropbox. And by Dropbox, that text file shows up on my computer as well. So the advantage of doing this complicated way is the message is very standard, and I know exactly when it was done. Actually, this should have the username who did it as well. I probably didn't copy that. Yeah, it should be there as well. And then if it's okay, then it's, so this becomes a kind of like a lab notebook, but it's centralized in a server. All right, so now I mentioned that we usually work with the last 4 characters of a very long RFID. And this is a place where many mistakes can happen, and that's something that we definitely don't want. We don't want to have wrong IDs associated with any of our nodes. So what we can do then is to give all the IDs we have to the app that lives in the server. And then whenever a note command is trying to record the ID, it first check if the ID is there, if the ID is a valid ID. So here I'm running a test, and the first 4 character is a valid ID. It can convert automatically into the full ID by the node server. And then the last 4 the second ID is a fake ID. Because there's no corresponding full IDs, then the app spits back, says, I don't know about that one. Maybe you need to check it. So this does not really prevent from a wrong ID to be associated, but at least it prevents invalid IDs to be recorded. Since we only use the last 4 characters, sometimes, even though it's very rare, the last 4 characters can be the same between 2 rats, and we want to prevent that. So with a little bit of programming, we can find out if this particular 4 characters is matched to multiple IDs. Here, it's in reality, we only use the last 4 characters, but I couldn't find an example of that the last 4 characters are overlapping. So I just picked the middle characters and picked this part, and that matched the few. So now it shows you that if the 4 characters match multiple full RFIDs, then it refuses to take the node and tells you to use 5 characters instead, because with 5 characters, there's no overlapping anymore. Okay, so now we handled the part of setting up experiments, and when experiments are done, animals are taken out. And if you have anything strange with the animal you notice during the experiment, and you can leave a note, and those notes are all standardized, be saved into the same central location and standardized, and standardized format, and they are very easy to search. And that is one big advantage of having an electronic version of the note compared to a paper version, just because it's so much easier to find anything that you want to find eventually. So now let's look at the data from the operant conditioning. So this is the raw data file from MEDPC. It's in this text format. It's easy to read, but it's not very easy for a computer to process, especially if you have multiple runs from the same animal. And I think there is now a MedPC provides a program that converts these raw data files into an Excel file. Before I knew such a program existed, we wrote our own, which basically is just a text conversion program. Again, there's nothing complicated. Just basically it looks at what A is and put it into the correct column. So anyone can write these programs. Doesn't have to be in a sophisticated language. You can use C if you are familiar with that. You can use R, Python, Perl, anything should work. And so that's what we have converting from these format into the spreadsheet format. And while you are doing that, you can also add a little bit extra that's not in the raw data file. So for example, here we added for each animal, we added how many sessions is this animal on, because each animal has its own, not each animal. So the experiment has a fixed schedule. The animal is on this dose for a few days, for 3 days, let's say, and then something changes. The session length may be changed to from an hour to 4 hours, and then the dose is getting increased, and then for a few sessions. So there's a fixed schedule for each experiment for all the animals. So by knowing which day that particular animal is, you know if the schedule is going to be changed or not. And if you know if the animal is going to be having a schedule change or not, and while you are putting the data in, you also know if next day the schedule needs to be changed or not. And if you know the schedule needs to be changed, then you can send a notification to the messaging system. So this is what we have. Once the data are processed, then right away it spits out this kind of message. Says here are the schedule changes for the day for this particular animal in this experiment, and it needs to be running in this condition, and that is for RFID. And this may look very familiar, and indeed this is exactly the same text part that we need for the spreadsheet. So the technician then copy these and paste them into the spreadsheet, and they find the animal and they replace it. And then once the spreadsheet is saved, then the macros are generated. Then the cycle goes on again. So in addition to reminding the technicians on which schedule changes need to be made, there are something else we can look at. Again, this is for air checking. One thing we look for is body weight change. If an animal loses more than 5 grams of weight, it's alarming. Why did that happen? Is everything okay? So once that's been found, there's a message that's been put in here, attached over here, and the technicians can check. Just to make sure if the body weight is recorded correctly, or the animal is sick, and if something wrong, they can then leave a note. Then we need to figure out when to run this. You can run this program 5 o'clock, but sometimes the experiments may go a little bit longer, and the experiment finish at 6 o'clock. So eventually we settled on running this every day at 3 a.m. But you want it to be run automatically. And this is slightly different from the first set of programs I showed you, where it's running all the time, constantly on the computer. This, you only need to run it once every day. So on a Linux computer, you can control that using something called a cron tab. And this is the way you set it up, very easy. This is 3 a.m. and then the command you want to run. So once you have this line of text in the cron tab, and this program will be run every day at 3 a.m. And whenever there's new data need to be processed, the raw data will be added to the spreadsheet, and then the schedule change for each individual animal will be showing up in the Slack channel, even when you have many groups of animals. The same group may have different schedules for different animals. It doesn't really matter anymore at that point. Each animal will be checked by the program, and they all have their own unique reminders. So that increases the consistency of the behavior procedure that's being done on these animals. So what else can we do with the nodes? The node system is actually quite flexible. Here I'm only showing you the keyword rat, and this is basically a program, right? And you can program it in any way you want. And the way we program it is we use the keyword rat to record rat-specific information, and that saves into its unique file. And there are other nodes that you can write, which I don't think I prepared any screenshots for you. But here I'm recording a rat has the node is failed Brevito test. And then the node says back, okay, I logged that for you. And you can use, if you want to have multiple rats, you want to record with the same message, all you need to do is put them into brackets. And that's being logged. And as I showed you over here already, that these are saved as a standard text format. And here the username is also preserved. So one of the advantage of that is whoever did that is already being logged, and the time is already being logged. So there's no extra need to write what time and which day this happened. Well, since we have this text at the back end, there's something we can do with these texts as well. So for Brevito test, we actually prefer to take these Brevito test results out from this long and long node text file contains miscellaneous information and put them into a database. Well, it's just picking out these, because these are already in a very standard format. We can then write a little bit of program and insert that into database. So that's also happening every night. If there's any Brevito test results, then the Brevito results will be automatically added into the database. And you also get a notification that these have been done. So this is on August 24th, and on August 25th, you get this message that these have been done. There is something else going on here, which is for some reinstatement experiments, we don't really have a good way to automatically save the data into a spreadsheet. So those are all still being done manually. But then when extinctions are completed, when animals met the criteria for extinction and they're ready for installment, the technician leaves a note in Slack, says these rats are ready, and then the next day, the so-called nightly analyst that looks over all the data can then send out this reminder that these rats need to be done, needs to have reinstatement session done on them. And then here is a text for you, and you can just paste that into a spreadsheet, and there you go. Macros will be generated. So that pretty much is our setup, complicated setup to do simple things that any technician can be trained to do for Auburn experiments. Now I'm going to switch gear and talk a little bit about using databases. So if you have not used a database before, a database is just like a spreadsheet. That's when talking about database, what I'm actually mean here is a relational database. So there are many relational database software that are available. Microsoft has its own Access. Oracle is a large relational database. There's just numerous databases out there. Most of them requires a so-called server running on a computer because it can provide remote accesses. Those are kind of overkill for what we need. We use database for recording the breeding paradigms, breeding data, and a few other miscellaneous data items. So in our case, we use something called SQLite as a database, and the graphical interface we use is called SQLite Studio. So what you're looking at here is SQLite Studio, part of SQLite Studio, a screenshot. Here's a database that has many tables. What I'm showing you here is a table called code color, and we have 5 code colors recorded. So one of the advantages of using a database is you can control the vocabulary that can be used. Here, what we have set up is for the code color table, we have a color column. And within the color column, we have 5 words used. And then in other tables, let's say a red table, we can also have a code color column. So you can imagine that you have a table of reds, and then you want to say this red 1 is code color black, red 2 is code color brown hood. And in that red table, in that code color column, we can specify that whatever words you use to describe code color must be already present in this particular, in the code color table, in the color column. In other words, there's only 5 words you can use to describe code color. Otherwise, the database is going to reject your entry. So this is a way we use to increase or to ensure the consistency of the vocabulary we use, so that we don't have BLACK space hood, we don't have brown hood, we don't have hood brown. So these are the only 5 variations of the 5 code colors we can use. So there's no other variants that are allowed in those in the data tables. And this comes very handy when we deal with red IDs. If we set up all red IDs in this particular table, then if an ID is not present in the all red IDs table, then it's not going to be accepted into the into those places where we have set it up. And what I just described is something called a foreign key concept, which is the content of a table, of a column, of a cell must already be present somewhere else. So that is the concept of a foreign key. And here is an example of a breeding table. We have serial number, KGID, and female ID, male IDs, and so on and so forth. And these columns all have been set up to have foreign keys. So whatever you entered into these columns for these in this table are checked against a separate column that's already been set up. So this causes a lot of, many times this causes troubles when technicians try to enter something. Oh, I have a foreign key error. What do I do? Well, you enter something wrong, right? So every time when that happens, it makes me happy because a potential error is being avoided. And now we have the breeding data in this table, in this database. So here's an example of the data table of the breeding table. What I just showed you is the setup of the breeding table. We can do something about these tables, these data. So there's a date of pairing, and then there's a date of birth. And once you know the date of birth, you know which day these animals need to be weaned. And then you can imagine there are a lot of other things you can do you can just take the database every day, look over all the breeding pairs and figure out what needs to be done, hasn't been done yet, and then send out reminders. So that becomes automatic. So that's all I have prepared, and just an overview of these services we provide to the technicians in the lab, setting up experiments. And one of the things I didn't talk about is we also create a PDF archive for the schedule. So we can go back years and see what's been done on that day, just because we have the schedule files are automatically converting to macro, and while that's been done, a PDF file is also generated with a date stamp in the file name. And there are lots and lots of notifications and automatic checking error at several places. So there are many advantages of doing that. Reducing the experimental error is a key for doing things this complicated, even though any technician can do whatever we have written programs for. It also makes technicians happier, I hope, that they don't have to do all these manual things. And the disadvantage includes it's somewhat complicated. It has many components, and it's fragile. And there are times when the computer is down and we need to do things manually, and people still need to be able to do them manually if the system is down. And we do need some programming skills, but I think nowadays with so many people are using R, even picking up a little bit extra programming skill is not that difficult. And most of things, even though I did not write them in R, can be done in R. We still have several manual processes left, but I think we will keep them as manual for now. And this is my last slide, just to show you a complicated diagram of what we have. So there is a MedPC computer that runs the MedPC program, and there is we share many files using Dropbox. You can use other cloud storage as well. And we have a Linux server. You can replace that with a Mac. We have a few programs written in different languages, but it doesn't really matter. And then we have technicians' computers. They all have spreadsheets, they have browsers, they have SQLite Studio, and they manipulate these spreadsheets, and something happens to these sheets, and then triggers the Linux server, and files generated, goes to the macros, goes to the MedPC program, and that's pretty much it. Over here, there's the app server. That's the one that's for the node system. It's living in a cloud somewhere. Here is the GitHub repository that have most of the scripts that I just described in there. So here is the Flask app, which is the Node app that lives in the cloud. It's not that complicated. Most of these lines are just whatever it's been repeated. So the structure of this app is not that complicated. Okay, I think that's all I have.
Fantastic, man. Thanks for doing that. So I see Shanak is fielding questions from anybody. Still have 31 of us on the webinar. Yes, while people are thinking of questions, I'll just say, hey, this is big bravo for me. You know, I can remember about 10 or 15 years ago, somebody used the term QA around me. I knew what QC was, but I wasn't sure what QA was. So I had to actually look it up, quality assurance. And it's something that we scientists don't really know about. We're all used to cleaning up data after the fact because we realize we make lots of errors during experiments. But it's brilliant to have tried to actually and successfully implemented the quality assurance steps in behavioral biology, minimize all those goofs so that you don't have quite so much work to do on the QC things. Big Pharma, of course, has been doing this for many decades. And unfortunately, most of us were trained to use lab notebooks. So scribble some ideas in a lab notebook, then scribble some of your results in a lab notebook and pray that it all made sense. But this is so much better.
Yeah, thank you for that comment. It all started as my desire of just wanting to setting up the animals in MedPC, like the first example I just talked. Just wanting to make sure that the animals are not run on a wrong program. And we used that spreadsheet for a couple of years without all the other components. And at that time, I was the only person who actually generates the macros. So even if I'm on vacation, I need to bring a laptop with me and make sure that I have internet access and I can generate the macros. It's only recently that I thought, wait, why can't I just monitor the spreadsheet and when anyone saves it, it automatically generates the macro.
Cool.
Yeah, amazing.
Question. This is Oksana. So I wanted to say that we in P50 Center, we're receiving data in HS-RADS from multiple labs, and the house data is like, it's the best data we have, like always organized. And yeah, so my question is, how long did it take to set up this? Like, you didn't like thought about it in the beginning, it was developing, right? So how long did it take you to develop this system?
Yeah, it's sort of like an ad hoc thing. I don't know how many years we've been using this system. At least 4 or 5. At the beginning of the P50, I think we have the MedPC, the macro program, and the Dropbox. Right. Yeah, that's what we had at the very beginning of the P50. And then later on, just piece by piece, I think we got a big increase in all these services once we realized we can use Slack, because Slack allows us to have notifications on cell phones. We don't have to write an app for it because Slack is the app. We just need to ask everyone to install Slack on their phones, and then we can deliver notifications to their phones. And then we started adding a bunch of other things.
I have a related question. Is like, the P50 has a lot of other projects that have some similarities. How portable would be your setup to other systems that you are aware of? I understand, I'm sure they're doing different things, but is there transportability? What do you think? Or is it like everything has to be done custom here?
I don't really know. At least in our case, everything is written for exactly what we need. But I think it's the idea that you can try some automation in the lab. I think that's the key message here. And the programming part isn't that challenging because most of these programming are not dealing with complicated logics or complicated algorithms. It's just you take some text format thing and you convert it into another text format. That's pretty much all the programming there is. And you run them at a certain time. And these can be done using a variety of tools or programming languages.
How do you think this could be part of the formal protocol, like the quality assurance step? We are working about, we're thinking about working on putting all the P50 protocols on protocol IO. And usually there is no step of quality assurance. It's just, okay, this is the behaviors which we measure and this is how we measure them. I'm thinking this could be very useful.
Yeah, I think that's possible. Again, in our case, it's all very tailored to exactly what we have in the lab and what happened in the lab. Many of these are in response to mistakes that took us a while to discover, like the body weight loss. It wasn't there initially. And then after a while, we realized, oh, some animals are losing their body weight. Why didn't we catch that earlier? So many of these QA are actually done after the QC. In retrospective, we reacted to that and added something in the program to prevent that from happening again.
There are a lot of you on that I see as participants that I know will find this useful. David, I know you're doing a lot of this. And I saw Rupert on there. Shahida, you're doing a lot of this kind of work. Any questions on implementation or packaging? David?
I'm Gregory. I have a small question. So why to choose Dropbox over all of the competitors? Like, what was the advantages?
It wasn't actually we actually did not deliberately compare the cloud storage options. We used Dropbox because I already had it. It was more of a convenience. And if there's any comparison of the features, I think Dropbox might be slightly better in terms of cross-platform or cross-operating system compatibility, because we have Linux, we have Mac OS, we have Windows, we even have like very small computers like Raspberry Pi in the lab that all uses Dropbox.
All right, but it's an impressive workflow that you did. It's very, very good. Thank you.
Thank you. Thank you.
Rupert, do you think Winter is this applicable for time series data, or do you see challenges for including high frequency time series data?
I do see. I've been thinking of putting something like this in place myself for the big cage, because we have the issue that some of the animals stop moving, and this is an indication that either the animal's sick or there's something wrong with the equipment. And it'd be really, really great to be able to pick that up in real time and have that integrated into Slack, which is really cool. But that's it's doable. But as you can see from the talk, it's quite a lot of work.
So,
I had a
go ahead.
I had a specific question for you, Hao, about the spreadsheet step, which is always, in my experience, a sticking point. Have you thought or experimented with having web-based spreadsheet interfaces that can just directly connect into a database backend?
So you mean something like a Google Sheet?
Something like that, yeah, or even a custom solution, just using some web browser HTML toolkit tools.
Yeah, we thought about that. I think that is possible. but I have not done it.
Yeah.
So
that might get around some of your issues with the Dropbox concurrency and so on.
Yes.
Because you're going into a nice, nice database that can handle that sort of thing.
Yeah, definitely. We have not done that. I think there's one case where we tried to program a Google Sheet, and that worked okay.
Yeah, I've done this the other way around, producing Google Sheets from databases, but not that way around. I've tried some much smaller scale with just with pull down menus and spreadsheet interfaces and so forth. But if you've got a relatively limited amount of interface that you need for a specific question, that might be doable. But if you really need the full power of an Excel spreadsheet, then this might be a daunting task.
Yeah. So one thing we thought for a long time is to convert SQLite Studio to an actual full-fledged relational database like MySQL or PostgreSQL, so on and so forth. We still haven't done that because maintaining another server is something that I don't want to take on. We need to, because if we need to set up another server, then there's another set of programming on the interface. And that is just a little bit too much for me to take on anytime, basically. And with the SQLite, even though we still have the problem of occasionally there is a conflict version in Dropbox because we share the database in Dropbox as well. What we've been doing is instead of launching SQLite Studio directly by the user, we have a script that puts a sort of a log file in Dropbox and then launches the SQLite Studio. So that's a lot easier than maintaining another server and write another set of user interfaces.
Sure. Yeah, so one of the things I like about the Dropbox solution or having it on a web, run through an ISP on a web database, is that you've then got access from everywhere, so that people can monitor this in the small hours of the night from home or whatever, and keep an eye on experiments that are running and be alerted if something that goes wrong in real time.
Yeah.
So Arthur, thanks for, I guess the recording will be going your way, but this is an area that you have quite a bit of expertise with using FileMaker in our group over the years. Do you see anything that would be really useful to Casey and Melinda and Shuhita and David that would be easy to add on or straightforward to add on? Since Hao is just 2 floors down, we don't have to hire him as an external consultant at $400 an hour.
Why not? Yeah, maybe some kind of I don't know if you are already generating notifications from your FileMaker Pro. Are you running a set of standard queries every day and see things that need to be done? That can be set it up. Even just, I know you are not using any Slack-like systems, but maybe just sending out emails can be useful, or just generate a file that on the database that things need to be done.
I personally think that would be cool. I think David working with Arthur could probably make it so. David, Arthur, comments?
Yeah, we are in the transition of moving our outdated version of FileMaker 15 to the new 19 version that will be hosted in the UT servers. We are in the process of that right now. I think we're probably going to take maybe another couple of weeks. But yes, something that we want to do is at least email notifications from I guess some errors or.
The weight loss notification would be useful for the aging colony.
Right.
Yeah, I think the idea here is as long as you have the data, you can write some kind of computer script to look through the data and find irregularities and send out some kind of notification. Yeah. So that it can be caught relatively earlier than going on for a long time before it's been noticed.
Mm-hmm.
Yeah, for mine, I think it's just a case of the time taken to set it up. It's not a simple plug and play kind of thing.
That definitely is the case, yeah.
Mm-hmm.
Looks exciting. This is looks fun stuff. You know,
yeah. So what are you talked about this a little bit, that packaging it as sort of a lab level app is going to be tricky because there's so many moving parts and dependencies. But if you had to package it into 2 or 3 bite-sized pieces, does that make it more practical? Or how, you know, in your diagram that you're showing us right now, what would the packages look like if you wanted to say, sell it or give it away for free to other labs?
I don't know.
So, I think there are 2 components I can identify. Okay, one component is you modify a spreadsheet and that sends an instruction to your MedPC or similar computer. And the other is something change, and you know, I guess the reverse, that you have data that is being constantly updated somewhere, either Dropbox or some other server file. And if it is being constantly monitored, some file somewhere is being constantly monitored, and you can set up rules that would generate a notification in Slack or Matrix Element or whatever the case might be, or Twitter, whatever your preferred messaging platform is. Right? Those are your money. The key idea is you monitoring a file and then triggering an action based on some rules.
Yeah, that's right. So one set is setting up the experiment. The other set is once experiments are done, look at the data and see if there's anything that needs to be notified. And the setting up part here is very specific to the particular program we're using, which is MedPC. It's very popular for doing operant conditionings, but there are other alternatives that does not take something like a macro.
Given the power of Raspberry Pis now, how much of it could you incorporate almost entirely within Raspberry Pi at the cage level?
We've done better than MedPC now, if I can say that. So you can basically use Raspberry Pi and make your own operant conditioning system. I think there's a few papers published on that already. But it's just the hardware part, the cage part is still difficult to make. It's difficult to make a good quality operant chamber.
Okay, but I was thinking of, yeah, that part I get, but how much of the meta structure that you've built around the cage could you integrate into a Raspberry Pi with a little SSD card, kind of distributed communication? In other words, how much of it could you offload onto a Raspberry Pi of the whole workflow? GitHub?
Everything.
Okay.
Yeah.
Wow. And the Raspberry Pi price that I realize you probably have to use a high-end Raspberry Pi, but
no, you don't need.
No?
Like I was, yeah. So most of these are just very simple scripts that looks at very simple text files.
But do you need an HDMI port into the Raspberry Pi for the cameras, I assume? And maybe, so how many ports can you put on a Raspberry Pi?
It has USBs.
Okay, and that's good enough. So you've got, and you can get a module for where you can put in 8 cages in a single Raspberry Pi, or is it cage by cage?
Oh, that's what I was thinking. Okay, that's what you're thinking. So you are thinking of a centralized, using Raspberry Pi as a centralized server that controls multiple operant chambers.
Yeah, maybe. Yeah, that's where it kind of was going.
Yeah, I was thinking one Raspberry Pi for one operant chamber.
Okay.
And then the data are sent to to a cloud central storage.
I mean, it's cheap enough probably to do that. I'm just thinking of Rupert and Winter, who will have 40 plus cages per system. So that if it's $100 per Raspberry Pi, that does get a little pricey.
No, it's 35.
35. Okay. Wow.
And there are others like more powerful. I mean, Raspberry Pi 4 is already very powerful. I don't even use, most of my applications are still on Raspberry Pi 3. And there are other alternative single board computers that are like in the $60 range that are much more powerful.
Okay. Okay, so that's not a problem then. And that does give you the flexibility of moving your cages around independently instead of worrying about how they're all hooked up together. Literally. Okay, thanks.
So we are developing our own operant system, even though we are using a commercial chamber. We are developing our own operant system with a Raspberry Pi, where we can have 2 animals doing operant conditioning in the same chamber by detecting their RFIDs. So in that setup, we use 1 single Raspberry Pi per operant chamber.
Okay, and how many cameras do you have on the cage?
0.
0. And so if you wanted to track, let's be over the top. If you wanted to track 8 animals in a single cage with 4 cameras, could you do that with a single Raspberry Pi?
The operant chambers are small, so we don't really put more than 2 animals in the same operant chamber, and there's stuff on top of the operant chamber that blocks the view. If you want to track home cage, then it doesn't really matter how many animals you have in the same chamber. All you need is 1 camera that covers the entire chamber.
Okay, so 1 camera is good enough. I would have thought even for rearing, so it doesn't help to have orthogonal cameras at
Yeah. In that case, it does.
Okay. So 2 cameras to a single Raspberry Pi, does that work?
I have not tried that. 1 camera definitely works.
I think for more cameras, you have to get an add-on board to allow you to use more cameras. I was looking at this a while ago. You can get boards that allow you to have like 2 cameras or 4 cameras and syncs them up so that you know what's happening at the same time. Because that's the other problem, that if you've got more than 1 camera, they can just go out of sync. So you're not having the same view at the same time.
Yeah.
Okay. Yeah. And so the GPU capabilities that you can bolt on to a Raspberry Pi will allow you to do real-time analysis on the Raspberry Pi?
I don't think so. I think it'd be a case of saving the videos and then analyzing them elsewhere, unless Hao knows otherwise.
NVIDIA has their own Raspberry Pi compatible version that has a GPU. We played around with it a little bit, but we didn't really do anything serious to know if it's good enough or not.
You'd think that if you've trained it,
yeah,
then you think you could just download whatever the training network was and have it do its business. That wouldn't be too burdensome a compute. The training step, I can see that's pretty burdensome.
Yeah, that is the case, but still, I would want to save the raw video if right. I have a camera set up, rather than I guess it depends on your goal. If you want to do something while the animal is behaving in a certain way, then real-time analysis is absolutely critical. But if you are only interested in recording, and if you can analyze the video data later, I would much more prefer to save the raw video than analyze in real time.
Yeah, I'm with Hao on that. But for example, you'd be looking at rearing and then you realize, oh, there's 2 types of rearing. And if you've analyzed it on the fly, then you've lost it. Whereas if you save the video, you can analyze it with whatever you want to do down the line.
Yeah, no, I got that. That makes perfect sense to me. But lean into it, pretend it's 10 years from now, and you don't have to verify because you've got it so well worked out. You just need to know what an animal is doing on a millisecond time scale. You want to do it for a couple of years, and you don't want to deal with a couple of years of video for 10,000 animals. So it's better to dump the data. In the same way for sequencing, nobody looks at the raw sequence data truly. You're not looking at the image files anymore. You just kind of they got it right.
Right. Yeah.
Yeah.
I'd still be nervous about not having the video files available, because even with the sequencing, sometimes I'll go back and look, oh, that's obviously wrong. It's a indel that's just not been called correctly or whatever. So yeah, I'd still be nervous about that.
Yeah, well, you can have your cake and eat it too. I mean, the storage space is not a big deal, but yeah, the number of times you have to go back is probably relatively modest compared, and I can understand it definitely for the QC final steps when you see weird stuff. But if, for what I'm thinking about what Rupert is doing now we're loading 60 animals into, 60 cages and recording for 2 weeks. And my God, the last thing in the world you need is that much video feed data, right?
Yeah, yeah. Yeah, even bin break data is useful, right?
Yeah. Well, cool. I'm really delighted that you were able to explain this to us, and we have it recorded. So people like Vivek, Umar, I think will want to watch this later. I think that'll be a big benefit for them.
Thank you for the opportunity to present this.
And thank you to everyone for joining us. I think we'll We'll call it a day then. I'll stop recording.